Hey everyone, and welcome back to The Explainer. Today we are diving into something really cool, a new AI image generator called NextStep 1. And what's so interesting about it is that it's taking a totally different approach to making these incredible images. So yeah, let's get right into how it works.
Okay, just look at this. On the left, you've got this absolutely perfect photorealistic snowy landscape, super serene. Then on the right, a flamingo made of fire and lava. I mean, come on. So the big question is, how can one AI model have this insane range? How does it go from perfect realism to pure fantasy like this? Well, the secret is all about teaching it to think about pictures less like a painter and a whole lot more like a writer.
So, we're all pretty familiar with diffusion models, right? They're the ones that start with a bunch of static and slowly, piece by piece, turn it into a picture. But the folks behind NextStep 1, they looked somewhere else for inspiration. They looked at the large language models. The ChatGPTs of the world that are basically running everything in AI right now.
What they're using is something called an autoregressive model. And the best way to get your head around this is to picture an author writing a book, right? They write the first word. Then, based on that word, they figure out the next one. And based on those two, the third one, and so on, just building the sentence word by word. This model does exactly the same thing. But instead of words, it's generating an image one tiny patch at a time.
Okay, but that immediately brings up a massive problem. A sentence is easy, right? It's already made of these little pieces, words, or what we call tokens. But an image? How in the world do you take a complex, visually dense picture and chop it up into a simple sequence of tokens without, losing all the amazing detail that makes it a picture in the first place?
And this is the exact dilemma that older models got stuck in. You really only had two bad options. On one hand, you could use these heavy, super slow diffusion models just to handle the tokens. Or you could use a limited set of discrete visual tokens. Now, that was faster, for sure, but it was basically like giving a master painter a cheap paint-by-numbers kit. You just lose all the subtlety, all the nuance. The quality just wasn't there.
And this is where we get to the core genius of NextStep 1. Because to crack this problem, the researchers didn't just tweak the old ways of doing things. No, they went ahead and invented a completely new kind of visual token.
They call them continuous image tokens. And if the old way was that cheap paint-by-numbers set, this new way is like giving the AI an artist's full palette. An infinite one, really. It can mix literally any color, capture every single subtle gradient, every little bit of texture in each patch of the image. It is a complete game changer for quality.
So here's a look at how this whole thing is put together. You've got the text prompt and all the image patches that have already been made. They all get fed into this absolute beast of a transformer. We're talking 14 billion parameters. But here's the clever part. All that brain power gets funneled into a much smaller, super lightweight component that basically acts like the artist's brush. Its only job is to generate the very next patch. So you have the giant transformer doing the heavy lifting, the thinking, and this tiny little head doing the actual drawing. It's a really smart setup.
Okay, so that's the theory. That's how it's supposed to work. But the real question is, what can it actually do? Let's check out some of the results because, honestly, they're pretty mind-blowing.
All right, here we go. First up, a koala wearing an Iron Man helmet, holding a sign with perfect text on it. This just shows you its amazing ability to get and then mash together totally different concepts into one single coherent picture.
And check out the texture on this one. It's a tiger cub, but it's made entirely of knitted yarn. I mean, just look at the detail in the individual threads, the softness you can almost feel. It's just incredible. And this is exactly where those continuous tokens show their magic.
And for our last one here, look at the composition of this scene. You've got this massive steampunk robot towering over a super detailed historical city. You've even got airships in the sky, and it all just blends perfectly into this one cohesive art style. Just amazing.
And hey, it's not just about making cool-looking pictures. The numbers actually back this all up. When you put it to the test on different benchmarks, the ones that check how well it can follow complex instructions or if it understands things about the world, NextStep 1 is getting state-of-the-art results for this type of model, for autoregressive models. And what's more, it's right up there, super competitive, with even the big top-tier diffusion models we all know.
But wait, making images from scratch? That's really only half the story. The real power of thinking about images this way, in a sequence, is how good it is at taking instructions to edit a picture that's already there.
This is just a perfect example. So on the left, you've got this cute little dog on a ship. The instruction was something like, turn him into a pirate on a stormy sea. And on the right, boom, just like that.
The model adds the pirate hat. It completely changes the background to a raging, stormy ocean, and it keeps the dog perfectly in place. This kind of editing, just based on an instruction, it's unbelievably powerful.
Okay, but as amazing as all this sounds, let's be real. No new tech is ever perfect right out of the gate. And to their credit, the researchers are really upfront about the challenges that are still left to solve.
So what are the roadblocks? What's holding it back?
Well, for starters, the paper itself shows some of the times it doesn't quite work. Every now and then, the model spits out these weird grid patterns or these little patches of noise. It seems to happen mostly when it's dealing with these super complex, high-dimensional continuous tokens. So it's definitely a stability issue they're still trying to iron out. And there are a couple of other major hurdles. First off, making an image patch by patch, it's just, well, it's slow. It's not nearly as fast as a diffusion model. Second, trying to train this thing on really high-resolution images is a lot harder than with other methods. And finally, if you try to fine-tune it, specialize it on your own smaller dataset, it can be surprisingly unstable.
So what's the big takeaway here? By treating pictures like sentences, by thinking about pixels like words, this AI can create and edit images with a whole new level of detail and, frankly, understanding. It really does build this incredible new bridge between language and vision. And that leaves us with one last big question to think about. If AI can now write an image with the same fluency it writes a sentence, what kind of story is it going to tell next?